folks, we're back with our next video. In our previous video, we were talking about simple random samples and different types of sampling. Now, a simple random sample is ideal, but is it going to be the most realistic option? So what are some reasons why a simple random sample, which can be abbreviated SRS, why might it be difficult to get? Well, maybe there are time or space constraints, right? So for example, if you're doing quality control at a factory, it might be difficult to physically locate any number of randomly selected products. So an SRS might be really challenging because if you'll remember, in a simple random sample, you have to number every individual in the population. Every individual in the population needs to be either written on a piece of paper or numbered, and that can be challenging. Another thing, like I said, is that it requires a known population. So when you're doing a poll for an election, it can be difficult to make sure that all potential voters are included in the population that the sample is drawn from. So while we would love to do a simple random sample, and we can do lots of great things when our data is collected through a simple random sample, it might not always be the easiest option. So let's go through a couple other random sampling methods that are not simple random samples. They're still random, so they're still legitimate. They're just not simple random samples. The next one we're going to talk about is a stratified random sample. Yes, another SRS, but we do not abbreviate it as SRS. So let's get some definitions here. What do we mean by strata? Well, by strata we mean groups of individuals in a population who share characteristics that are thought to be associated with the variables being measured in a study. So that if you were to do a stratified random sampling, that's when you're selecting a sample by choosing a simple random sample from each stratum and then combining the simple random samples into one overall sample. This is kind of, the way that I remember stratified random sampling is I like to think of my Aunt Nancy. When I was a little girl, my Aunt Nancy always taught me that when there's, end of the meal and there's like a dessert bar, if, it's a big family get together and there's lots of desserts, that you should always have a little sample from every single dessert that's on the dessert table. That would be like a stratified random sampling. You're taking a little bit from every group, and each of those groups are alike in some way. So I maybe take one of the cookies from the cookie tray, and then one piece of pie from the pie plate, and then one piece of candy from the candy tray. Now, how are you going to divide your population into these strata groups? Okay, so this is what you're going to do. You're going to divide your population into the groups, and then you're going to do a simple random sample from each stratum, and then combine to form the full sample. Now, this works best when your individuals within each stratum are going to be similar, right, or homogeneous, with respect to what is being measured, and when there are large differences between the strata. We can choose strata that have similar responses within strata, but different responses between the two. Okay? Stratified random samples give more precise estimates than simple random samples of the same size. So, in fact, it's kind of superior in that way. It's going to reduce your variability of what you're estimating. Let's look at a couple of different examples of ways that you can do stratified random sampling. If you're doing a survey on Medicare changes, you could do your strata based on age brackets. Because, within different age brackets, they might have similar opinions, but between different age brackets, they might be different. If you're doing a survey on sleep patterns of high school students, you could do strata based on grade levels. Maybe freshmen have similar sleep patterns, and then seniors also have similar sleep patterns, but they're different between the two grades. And then when doing a preliminary election poll, districts may be divided into rural, suburban, and urban. Perhaps those districts are similar within them, but different between them. Okay. Here is a visual representation of stratified random sampling. So if somebody had a list of clients, then you could divide them by their ethnicity, and then you would pick some from each group. Okay. It can be, like, students often wonder, like, well, how many do you know how to pick? Well, there are a couple ways you can do it. You can either pick the same number from every strata, right? So like maybe I pick 5 from here, 5 from here, 5 from here. Another way to do it is to do it proportionally. So if you have a much larger group, so like let's say in this example, maybe there were more Caucasians than there were African Americans, then proportionally you would pick more Caucasians than you did African Americans. So that way, even though like the number of one group is bigger than the other, it's proportional for how many are in each of those groups. There's no one right or wrong way. Either way is fine. Our next example of a random sampling is going to be cluster sampling. Okay? When populations are large and they're spread out over a wide area, we prefer a method that selects groups or clusters of individuals that are going to be near one another. So that's going to be our idea behind cluster sampling. So cluster, the definition, is a group of individuals in the population that are located near each other. That's it. It's the fact that they're close in proximity. That's why we like them. So then cluster sampling, you're going to select the sample by randomly choosing certain clusters and then including each member of the selected cluster in that sample. Okay? If I was to go back to like the dessert table analogy, this would be like, oh, look, all these desserts over here, and then I have different like sections of desserts, and then I would pick an entire section and eat every dessert in that section. Okay. What was I going to say? Include each member of the cluster. Yes. So it works best when the individuals are heterogeneous, meaning mirroring the population. So they're different within the groups. That's why you're going to choose the entire group when you sample. We often use cluster sampling for practical reasons, like saving time and money. If you were to think about, our school, what would be a good way of picking a cluster? If you were in chapel, you could use rows as clusters. There's a variety of genders and ages that sit amongst the rows. And so if you pick, number all of the rows, and then you randomly choose a couple rows, and then you'd ask and sample every group in that, or every individual in that row. Here's a visual representation of the difference between cluster sampling and stratified sampling. Here's another visual up here of clusters. So the clusters are where they live, 1st Avenue, 2nd Avenue, 3rd Avenue, and then you would randomly choose one of, a cluster and then pick everybody in that row. You can see down here the difference between stratified and cluster. Hopefully you're not colorblind. Stratified, you can see how each strata is similar in some way. This is by color. And then you pick a couple from each group. Cluster, you can see that each of the clusters is different, but the clusters that you then choose, you sample from everyone in that group. Next one we're going to talk about is systematic random sampling. Systematic random sampling selects from an ordered arrangement of the population by randomly selecting one of the first K individuals and then choosing every Kth individual thereafter. This can be particularly useful in certain contexts. Here's an example. At the exit polling on election day, since you're unsure of how many voters are going to come, you'd be like, all right, well, I'm just going to ask every 10th person who they voted for and just keep going until I've run out of people. A caution against systematic random sampling: if there are patterns in the way that the population is ordered that coincide with a pattern in the sample, then the sample might not be representative of the population. Here's an example of how you would do a systematic random sample. So let's say we have 800 students and we want to sample 80 of them. So if you divide 800 by 80, you get 10. So this is different than the polling example one because I know how large my population is. So if you divide 800 by 80, you get 10. So that means, all right, I need to sample every 10th student. So as students come through the door, you number them, right? Just be like, you count 1, 2, 3. So you need to pick a random place to start. So you would randomly select a number between 1 and 10 using like a simple random sample strategy. So let's say you pick 6. So then you would survey the 6th person to enter the door, and then you just systematically survey every 10th from there. So the 16th person, the 26th person, etc. That will ensure that you have your sample of 80 students and you're doing it in a systematic way. The ones that I've just talked about, the stratified, the cluster, and the systematic, there is an aspect of simple random sampling within all of them. When it came to the stratified, you did have to, pick the people within each strata through a simple random sample method. The way you would pick a cluster is through a simple random sample method. And then same thing with where do you start for the systematic. So they all involve a little bit of a simple random sample, but it's different in the big picture. All right, I want you to follow along with me in this example. We're going to do it together, looking at different ways we can get random samples for this particular example. So if you can see, there are 16 plots and this represents a cornfield, and what we're trying to do here is we're trying to estimate the corn yield. So instead of going to every single plot and looking at every single stalk of corn and seeing how much corn is on or in that area, we can do random samples in different ways. So we're going to go through all 4 options that we've discussed. So how could we choose a simple random sample of 4 of the 16 square plots? This is actually a pretty wordy thing. Like, you need to be very specific with how you would do this. So here's where we start. The plots are already numbered, so that kind of takes one thing off our plate for us. You can either use technology, and you can use a random number generator, or you could use a random digit table. So if you're going to use technology, and you would use a random number generator, you would use that to select 4 unique random integers between 1 and 16, and then you would then select those plots and measure the corn yield in them. If you were to do a random digits table, so like table D in your book, you would number the plots from 0, 1 to 16. So this is slightly different because you need to make sure that every plot has the same number of digits for its label. Starting at a random place on the table and then reading from left to right, you're going to choose 2-digit numbers that are within our range, ignoring any numbers outside of our range and also ignoring repeats. You're going to continue until you have 3 different numbers between 0, 1, and 16. That's a misprint. You should have 4. So you have 4 different numbers between 0, 1, and 16, and then you would select the plots that are corresponding to those numbers. Students always forget this last part, where like, okay, you pick the numbers, but now what? Well, you look at the plots that have those numbers, and then you sample from them. How could we do a stratified random sample of 4 of the 16? So with stratified, you need to make them into groups that are alike, and then you pick some from each group. So in this case, I'm going to divide the field into columns for my strata. So in this case, the common characteristics is their proximity to the river. Everyone in this column to the right is really close to the river versus all the way over here, they're all really far. Then I'm going to randomly choose one number from each column using like a simple random sample strategy. Then you're going to select those plots that correspond to those numbers as your sample. Let's look at cluster. So again, cluster, they're near each other, but they're different in certain ways. So in this case, I'm going to choose my rows as my clusters. So the plots are close to each other, but they're going to vary in their proximity to the river, which may in fact be a factor in affecting their corn yield. So then I would randomly select just one of the rows, okay? And then I would use all 4 plots in that row as the sample. Last but not least, how could we do a systematic random sample of 4 of the 16 square plots? So 16 divided by 4 is 4. So you're going to choose a random place to start between 1 and 4, and then you're going to select every 4th plot. So for example, if you started at 3, then you would also have 7, because 1, 2, 3, 4 gets you to 7, 1, 2, 3, 4 gets you to 11, and 15. This would be one of those examples where it's not good to use systematic because all of those are in the exact same proximity to the river and so aren't a very good representation of your whole population. What I want you to do now is to stop this video, pause it, and turn it off because this is your task for the rest of this video, is to explain how you would do simple random samples, stratified random samples, and cluster samples for the scenario where we have a librarian in the bookstore, and we will go over these answers in class together. All right, thanks guys, good luck.